Welcome in everyone to Tofu Tech Talk. I have a fabulous guest prepared today, who is not science. I will change that label. That's a mistake. We actually have VolcanoDoc here today. Welcome in, VolcanoDoc. Would you like to introduce yourself while I fix your label? I'm so sorry.
Of course. Thank you so much for having me. So welcome everybody. I'm VolcanoDoc. I am a volcano scientist. Originally, so I'm over here on the States on the West Coast. Originally, I'm from the center of the country, moved to California to go to grad school. Um, got my master's at Fresno State in right by Yosemite, if you're familiar with kind of where that is. And then I moved down to Santa Barbara, got my PhD at University of California, Santa Barbara. Now I live about 40 miles south of Mount St. Helens, which is really, really cool.
I
But
know that. I know
going to
Helens.
be moving. Yeah, I can see it from my house when the sky is clear, which is really awesome. And I'm definitely gonna miss it because I now will be accepting an appointment as an assistant professor. So I'm officially Professor VolcanoDoc, and headed back to the Midwest so I can find more Midwest people to become volcano scientists and do good things.
No, that's absolutely amazing. And okay, we have to ask. So when I was tiny toxic tofu, I got my doctorate just not even a year ago, like 6 months ago, or whatever. Um,
Congratulations.
we were talking about changing my name to Doctor Toxic Tofu when that happened. Now, are you going to change your username to Professor Volcano, or what are you thinking?
No, no.
No rebranding.
I've had this for since I think, gosh, since 2016. I've
Oh
been
my
Volcano Doc for
days.
8 years, so like, gosh, I don't think I could.
Have you been
It'd be so
streaming on
strange.
Twitch for 8 years?
No,
Oh, okay.
no, I was on Twitter. I migrated over from Twitter to Twitch during the pandemic, kind of.
uh,
So I'm a pandemic streamer. It'll be 4 years the end of May, and yeah, I did. I definitely was more involved in Twitter before its downfall, because I think that it's a very good place to collaborate and see what other people are doing. And the when you're in a very small kind of group of people that are also earth scientists and academics that do exactly what you do or do similar to what you do, it is just like a tiny little Discord. It's really nice. But since Twitter kind of disbanded and
has
it's there
actually
a
just
little bit,
I'm
but
very behind Twitter. I only got into it like 3 months ago, so I'm very baby new to it. Has there
ah,
been an actual major downfall in it?
in a lot of the scientists, at least, a lot of the scientists have
Oh,
migrated over to Blue Sky.
blue
So
sky.
some people are
Gotta write that
still on
down.
Twitter. And so it's kind of a balance between Twitter and Blue Sky and Twitch, for a couple of us who are over here. But yeah.
Nice. I wrote that down. I'm gonna check that out. That's really nice. But it's so cool that
Oh
you switched over from Twitter to Twitch. I know we should be talking about science, but before we get
yeah.
sidetracked on the other sidetracked of the second sidetrack, um, yeah, like so you started streaming pandemic. Do you only stream science and tech segments, or do you play games? Is there anything else that you do on Twitch, or what is your Twitch about?
So it's predominantly volcano science. I started my stream trying to figure out how I was going to do online classes, and I started just kind of like recording my disasters lectures because I was teaching a class on natural hazards and disasters, and people really liked that. So I started doing Volcano Science Sunday, which I still do. I still stream every Sunday. The time is a little fluctuating, but I do play some games. I really like first person shooters. I really enjoy the Sniper Elite series. I'm obsessed with Far Cry 5. I don't like the gameplay mechanics for 6, and I'm very excited about the 7 trailer that just got leaked, though. And Cat Quest, which is adorable.
That's amazing. I can't believe first shooter is very very specific. I think you have to have a very specific taste for that game. I'm not very good at shooter games, so
Oh, yeah.
uh,
I like
yeah.
first person snipies.
Nice. Snipes. Yeah, no, snipes can definitely be, you know, satisfying. But to get back on track about science. So, you are, what would it be fair to call you? A geologist, a earth scientist? What is a classification? What is your area of expertise?
All of the above. Um, so I am a volcanologist and igneous petrologist. A volcanologist is a volcano scientist. An igneous petrologist is somebody who studies how igneous rocks are formed.
Mm.
Igneous rocks are one of the three main types of rocks. There's igneous that come from volcanoes, cool from magma or lava. Metamorphic, which are when you get other rocks that get changed by pressures and temperatures. And then sedimentary, which are formed by, you know, bits of grains of sand and things coming together and going through a couple different processes to become a rock. So I study the first kind, igneous rocks. Um, all of those are kind of like subsets of geology. And because igneous rocks are inherently, have to do with volcanoes, and they're either a cooled magma system or cooled lava, that's kind of where my focus is. And so I'm really most interested in eruption triggering mechanisms. Um, Inside of a magma chamber, there are lots of different things that can happen in order to make a volcano erupt. Like even just different styles of things that can happen, completely different reasons why a volcano will erupt.
Okay.
And so I'm very interested in understanding what those are and like exactly what happens. Like what's the one thing that sets that volcano over the edge for that particular eruption. And
Okay.
it can range for lots of different there's lots of different mechanisms, which is pretty cool.
I suppose
And
that's kind of a good way to start off the interview in asking, so what are the triggering mechanisms? What causes
oh,
volcanoes? Is it the same? Like, would you overlap in your studies with earthquakes? Just from a simple perspective of my intro of physics and everything in life, we are on plates, right?
we are.
We are floating on on magma. Is that the right term? Or
No, not
no?
really. So the mantle, the different layers of the earth. There's the core, which has a solid inner core, liquid outer core, and then we have the mantle, which is essentially it's a solid, but it's a ductile solid. That means that it like flows over like millions and millions and millions of years. I think it takes like something like 250 million years for one convection cycle in the mantle to move. I mean, the
How many
Earth's
years?
really big. 250 million, I think.
One convection cycle.
Yeah, so they trace this by looking at isotopes in it's like the time between subduction of the slab and then when that slab gets drawn down into the mantle, it can either go all the way down or sometimes thick, shallow,
Mm-hmm.
convect, get homogenized, and then parts of it erupt out of a volcano. You can use isotope tracers. That's not something I do. I just know that I just know that this can be done. I learned about it from a guy who does do it.
Mm-hmm.
Um, and so that's, you can actually take the time it takes for a plate to get subducted and then magma to form from that subducting plate and then get erupted back out of an arc volcano. Um, then like, yeah, it's like 250 million years or so.
Wow, I didn't know that's how long it took. Holy smokes, that is.
Yeah. And moves very slowly. The mantle
Mm,
is a solid.
mm,
And you think about like plates, the tectonic plates move a couple centimeters a year. So it's not
yes.
really
Mm,
that, I'm on a person time scale, it's very, very slow, but you know, 250 million is not that much when you're 4.5 billion years old.
mm. Yeah, no,
You know?
it's very, very slow. Understandably. I guess I'll jump in to ask this question.
Yeah.
Could you differentiate to me why and when does a volcano get formed? So, from my understanding of geophysics, geology, not sure what the classification is, we're just earth science. in total it. The mountains form because two plates push together or against or whatever way is happening, and they build rock on top of each other, right? Or they fold. It depends what's happening, right? There's fold mountains. Is that fair to say?
Those those are traditional
Science.
tectonic mountains, and
Hmm.
yes.
Then what happened? So, but that also sounds like something that a volcano is as well. Is that volcanoes also are formed at the plates? Is that fair to say as well?
It's fair to say that volcanoes form along different plate boundaries.
Mm-hmm.
They don't form at all plate boundaries, however, and from they're not forming from two plates kind of coming together and crumpling and pushing upwards. You do find you I guess first off I'll say there's three different types of plate boundaries.
Mm-hmm.
There are divergent plate boundaries where two plates are being pulled apart. They're
Mm-hmm.
not pushing, they're actually being pulled apart. We know that now. Then we have a transform plate boundary, which is like the San Andreas Fault. I know that you have many in Europe as well. And those are ones that go side to side. And then there are subduction zones. So that's what the Ring of Fire. It's literally only called the Ring of Fire because it has volcanoes all around. All of those volcanoes are caused by plates subducting under the other. So when you're building up mountains, which is a process called orogeny, you're
Fair.
pushing together two plates that are of about equal density, but neither are dense enough to really sink into the mantle. So they have to kind of stay up on top of the mantle, and that's why you get tectonic mountains. Uh, with subduction zones, you've got one plate that is older and colder and more dense, and one that is younger and warmer and less dense, or a continental plate, which is less dense because the chemistry is different. So you will have an oceanic plate subducting in a subduction zone, and that's because it's more dense than the mantle. So it gets kind of sucked down, and then as the denser plate dives underneath the other. Exactly, Otarik.
Mm.
And what we know now is it's that density that actually helps to drive plate tectonics. It's that the subduction is the plate tectonics driver. Plates at divergent
Oh.
boundaries, they're not pushed apart by the mantle. The convection the push force of the convecting mantle is far outweighed by the kind of like pull force of the denser plates going down. Because as they go deeper into the mantle, there are lots of different changes in the minerals and the structure of the minerals inside the plate. And they actually turn into metamorphic minerals that are heavier and more dense. And so they kind of pull it down even more,
Mm.
until they reach a zone of neutral buoyancy in the mantle.
Mm.
But yeah, I where was I going with that? Oh yes, why do volcanoes erupt where they do?
From or form, basically, yeah.
So at transform plate boundaries, you don't have any sort of way for magma to come up or be made. So we don't have volcanoes there. Um, with divergent plate boundaries, you have lots of space being made. And so that allows magma to kind of come up and fill that empty space more passively. And that is a good example of a place like that is Iceland. So Iceland has a high rate of magmatism because it's at a divergent boundary, but it's also at a hot spot. And a hot spot is where you have a bit of the mantle that, for whatever reason, the Mid Atlantic Ridge. Yes, that's a divergent plate boundary all the way down.
Mm.
And so, yeah, Iceland's on a hot spot, which is kind of like a mantle plume. It's a bit of the mantle that's hotter, and so it can kind of rise upwards, even though it's not at a plate boundary. Mantle plumes can kind of form anywhere. So Hawaii, um, Tenerife. Trying to think of other ones that are uh,
Okay.
Yellowstone. Those are
Yes.
all mantle plume volcanoes. And then subduction zones, like along the Ring of Fire, when that plate goes down, it can melt the mantle above it and make a magma. And then that magma comes up and erupts out as volcanoes.
I
So
see.
that's why they occur at those plate boundaries.
Oh, okay. Thank you so much for that in-depth explanation. I will go
Yeah,
through all the
sorry.
questions, but I just because Tarek's one is really in theme with what you just said, so we stay in the same area. Do these boundaries change the speed and the that these plates move? These
Hmm.
boundaries that you were talking about, does it change the speed of the plates, or they already move so slow compared to our lifespan that there's no noticeable difference?
So there are different rates of spreading. It does change depending on the plate boundary. Usually, uh, the normal average rate of plate movement is about 3 centimeters a year. You can get fast ones. There's one, the East Pacific Rise, which is in like off the west coast of South America, has the fastest spreading rate, and it can be between 6 and 16 centimeters a year. Everything is very, very variable.
Wow, so much, 16 centimeters in comparison to the three. Because I also studied in school that was only 1 or 2 centimeters that they moved. So that,
Yeah, well, so there's fast spreading ridges and
mm,
slow spreading ridges,
mm,
and it all we don't really understand why they occur. At least I'm not sure why they occur where they do.
mm.
But I don't think what kind of controls the subduction process, that's still very hotly debated.
Mm. And just to continue on this topic again, I'll go through the questions properly. There was a lot there.
Mhm.
But on the
Yeah.
topic, with the subducting plates that you mentioned earlier, do the plates melt into the mantle, or is it reversible if the plate pulls away? I kind of have to add a little question of my own to this, is that if one part of the plate is pulling, let's say we're talking about plates floating. I know it's not technically the right term, but on one part they're separating and another part one is dipping into the denser one is dipping in, and you're losing plates is the way I'm seeing it. Are you regaining mass? Are you regaining a plate in any way
Yeah, the divergent boundary.
that creates a
So
plate? Does it?
that's the creating, yes, that's creating the new plates. So if you look at the west coast of South America, um, then you can see there's the East Pacific Rise kind of goes from the bottom of Mexico towards Antarctica, but at South America, you have subduction. So it starts like you kind of think about it as you make new oceanic crust at a plate boundary. So the
Mm,
oceanic crust gets created at the plate boundary, travels, along the mantle, and then gets destroyed in the subduction zone. So it really is like a cycle. You have complete conservation of mass.
yeah, perfect. That I suppose that answers both of our questions.
Yeah.
And
Well, it's not quite for spookies. This is
oh,
a very good question. It's a really good question, Spooky, because this is one that a lot of undergrad geology majors have an issue with, and it took me a lot of time to understand even. Because you want to think that, oh, that plate's going to go down in the mantle and it'll melt, but that's not quite what goes on.
okay.
So if you have like, say if this paper is the Earth's mantle and this is the subducting plate, do you see how there's still paper above it?
Mm,
So once this plate reaches like 100 kilometers inland, roughly about, it's so dense, and it's like too hot and dense for the minerals to exist how they originally were. So water starts to kind of come out of the crystalline structure from the minerals that are on top of and in the uppermost bit of the plate. And that water rises. It goes from the plate up up here into the overlying, we call it the overlying mantle wedge. It's the bit of the mantle that is above the subducting plate. So when you add water to a rock, it makes it easier for that rock to kind of melt because of very weird mineral phase relationships. And so you're actually melting the bit of the mantle above the subducting plate. That is what is melting and generating your magma.
Okay. Thank you so much for explaining that.
Yeah,
Those
no,
spookies happy
I'm
in the
really
chat.
glad Spooky asked that. That was a great question. Yeah, it melts. Well, it not melts the other plate, Spooky. It melts the mantle, the stuff that's in between right here, and then that rises up. Yeah. Sorry, we've got some very good questions
Oh
in
my
chat.
god, the amount of questions. I'm going to ignore Spooky's first question. Spooky made himself very, very smart, but he also asked earlier, where do lizard people live? So we're not going to cover that. A running joke on the stream is because I never heard about Hollow Earth theory or about lizards, and then I opened one Wikipedia page and it was a 2-hour stream. It was, yeah, no. That's the running joke behind the question. It was all good crack, all good banter. I'll go through the questions slowly bit by bit. I have so many questions as well, but chat will take priority. There was another question. Is there any direct material that can be farmed from volcanoes? So that's a bit of an interesting question, such as sulfur. Oh, there we go. Sulfur for sulfuric acid, or what's the standard production?
So there is Kawa Ijen. I'll put it in chat. And you can, there loads of Wikipedia pages. There's BBC documentaries about Indonesian miners who literally have to hike up to the top of this volcano, and it's such dangerous work because they're literally collecting sulfur that comes from the holes, and it's hot and there's volcanic gas.
And it's dangerous. Sulfur is
horribly dangerous.
Yeah.
Horribly dangerous. But it's actually used in sugar production. So in addition to all sorts of other industrial uses, there's a lot of reasons why we use sulfur, but this is how it's mined.
Wow. That must, oh Jesus, I can't even imagine having a job description like that. Holy smokes.
Yeah, it is very sad. It is very heartbreaking to watch a documentary like this and understand how dangerous of a situation those miners are having to put themselves in every day because they need the money.
Thank you for explaining that. I really didn't even think about the fact that we would be mining anything from volcanoes. I didn't even really know about that before. So both of you, thank you so much for pointing that out.
No, it was a good question.
A question from Naz is it possible for volcanoes to form away from plate boundaries due to an extreme hotspot? So I think you kind of mentioned that already, right? You did say that you listed a few examples, if I'm not mistaken.
Yes, those are the mantle plumes. So when the plates get subducted, we don't really know why they end up where they are, but it creates weird heat distributions at the core mantle boundary. And the current thinking is that maybe where those plates land inside the Earth might unevenly heat the mantle, and that's what controls why these hot spots kind of form where they do. That's our best guess.
The best guess possible at the moment. It must be a really fascinating field because I feel like there's a lot of updated theories and models constantly in articles in earth science. Would that be fair to say?
Oh, well, yeah. So, how old is physics?
Very old.
Geology as like even kind of a modern science. Even like literally just the study of like fossils and rocks and layers of that, it's James Hutton in the 1800s. It's a very, very young science. And, we, as far as plate tectonics and understanding how the plates move around and how that relates to, earthquakes and volcanoes and how our Earth works now, that was not widely accepted until the 1960s. Um, I actually so one of the professors where I did my PhD, her name is Tanya Atwater. She was the first female earth scientist allowed on a research vessel. And she is the person who figured out how the San Andreas Fault formed and the plate tectonics of history of Western North America. And she's alive and kicking. She's great. Like, she's in her 80s. I want to say like late 70s, probably late 70s, early 80s. And she's awesome. She's a wonderful woman and a brilliant scientist. And the reason I bring that up is just to kind of illustrate how young geology is as a science.
Yeah, no, I couldn't imagine. I guess when you compare it, there's so many eons of years to go through in physics. I mean, it's one of the common topics we do on the science and tech segment. We talk about some of the scientists from way, way back, and we do a whole study about their lives and things like that. But yeah, we were talking about, I feel like we mentioned it recently about some of the new fields of science. And I did think we did mention geology being one of the newer and cooler fields. Does that mean, out of pure prying, does that mean that there's more funding, or is it the opposite because it's such a new science that it's more stingy funding from I don't know. I guess you wouldn't know how to compare it, maybe because of the application process, perhaps, and things like that. But I wonder, verbally, do you think it is easier to get funding compared to other sciences?
I think it depends on what you're working on.
Okay.
I genuinely don't know. I think it might be easier for, like, microbiology and people that have research that is useful for pharmaceuticals and medicine and stuff. I feel they get a whole lot more funding than we would. But part of our science is outer space and planetary geology.
Yes.
So a lot of geology funding is through NASA. Goes to NASA, which they actually cut our funding. The U.S. cut, like, NASA funding, all science fund. It's like they cut it down significantly. It's really stupid.
Sorry, I didn't mean to get you worked up.
Yeah, no, I know. So for, like, people like me who research, how volcanoes work, there's a lot less funding than for somebody who might be looking at, like, medicine, or even like oil, gas reserves, stuff like that. Things that our world is more driven by will get more funding.
Yeah, that was kind of like perfectly in theme the way we sidetracked to ask some questions. There was some question about is space volcanology a real discipline?
Mm-hmm.
It
It sure
is.
is.
Oh my
Mm-hmm.
days. And I suppose the question is, what's the largest known volcano in the solar system? Is it on Earth? Do you know on top of your head?
No, it's
No.
it's not on Earth. It's Olympus Mons on Mars, which is extinct, as to my knowledge.
Oh, okay. And I guess active wise, it might be Io, one of the moons of Jupiter, right?
Io is the most active body in our solar system, but it's because the gravity
Yeah.
between, like, Jupiter and stuff, it like keeps the inside super hot.
Mm. Yeah, yeah. Understandable. Oh, I spoke of Otto the potato. He's here. Welcome, Otto the potato. Only
Oh,
specifically you, because I know you love rocks, and we have an igneous rock person here with us. Otto shares rocks pictures with us all the time, so we're very excited that he was able to catch the stream. I will go through the questions. There's so many. Holy smokes! I can't believe there's so many questions. There's an interesting question. Which films are the most realistic in terms of what it would be to experience an eruption? Have you watched any volcanic based movies? I can't think of
I
one on top of
try
my head.
not to. I try not to because I get very frustrated with them. Um, I will say, out of all of the disaster movies, Dante's Peak is probably the most realistic, uh, in term, like, as Hollywood movies kind of go. Um, there was a new documentary that came out last year called Fire of Love about Maurice and Katja Kraft, who were more well known in Europe, but they were rather a pair of French volcanologists who genuinely were like the first volcano science communicators and went around videotaping and just like trying to bring volcanoes to people. And yeah, Otto saw it. And so I would say that's my favorite because it uses their actual footage. It's footage from their estate that had never been released before because they died in the 1991 eruption of Mount Unzen. And
Oh.
it's really just a phenomenal movie. I cannot recommend Fire of Love enough. It is, I probably watch it like once a month.
Oh wow.
It's so good.
So Fire of Love, and what was the other movie? Dante's Peak?
Yeah, Dante's Peak is like the Pierce Brosnan Hollywood one, and yeah, they had insane footage. The footage that the Crafts got was just, uh, yeah.
All right, perfect. I've noted those down because I also have notes from Science TofuTechTalk as well to see what are ants good ants based movies. It's a good question. I really like that. There is another question, but it might be sidetracked. I'm going to ask a question first, so it'll lead on naturally. You mentioned that you study a volcano in New Zealand. Is that right? Could you describe a little bit more about that for me, please?
So it's near New Zealand. I was
Oh,
incorrect at
Tonga.
first.
Sorry,
Yeah,
my
yeah.
bad.
So
No,
it's
no,
in
no.
Tonga. Um, I'm not sure where people in chat are from. Hey, not the brain. How are you? Otto, if you're from New Zealand, you will certainly remember the big eruption January 15th, 2022 of Hunga Tonga Hunga Ha'apai. It was basically the modern analog of Krakatoa. It produced an obscenely high eruption plume that went 58 kilometers, which is over halfway to space. And it is just like one of the most fascinating eruptions that I have ever had the privilege to study. Actually, and so what's really cool, hey Dr. Dirk, what's really cool is that when it erupted, it was like uh gosh, everything went all over Twitter because this is the first like huge, there's a special type of eruption when water gets involved, but it's super duper massive. And it's called a phreatoplinian eruption. Like I have a PhD in volcanoes, and I didn't know that this existed. Like
Okay.
that's how niche it is, but like that's how powerful it is. And I, this happened on I want to say Sunday in Tonga, so it was Saturday night here, and so the next day on my stream, we were all like looking at all the video footage and everything because everybody was so concerned. About an hour after the eruption, or an hour and a half after the eruption started, or the biggest part of it started, um, the undersea internet cables to Tonga got cut by a pyroclastic flow. And so the entire country was cut off from the rest of the world. Nobody knew what was going on. All we knew is that we saw this giant volcanic eruption on a satellite. And we see starts of pictures coming from people are posting on Facebook, and then nothing. The entire country is quiet. And so I remember like the New Zealand was, and this was like during COVID too, so everything was very dicey. We didn't know how many people died. We feared the absolute worst. And to the Tongan people's credit, they are so well disciplined and well prepared and trained for tsunami and know the signs of a tsunami that, I mean, the I think the largest tsunami wave was 45 meters high, and or that's the wave on the nearest island, and only 7 people died.
In the whole accident, in the whole
Yeah,
incident. Oh my days.
5 in Tonga and 2 in Peru.
Okay.
So it's genuinely a miracle that this did not turn into a Krakatoa.
Mm-hmm.
And I mean, Krakatoa is known for because it caused so many deaths. Mechanically, in my professional opinion, mechanically, insofar as we know, The eruption trigger for Tonga and Krakatoa were probably the same or very, very similar.
That
But
water thing that you mentioned.
the yeah, the water.
Okay.
But because so few people died in as a result of this eruption, I think that only people who really study volcanoes will remember it. I don't think it will be remembered the same way, which is unfortunate.
I was wondering because you said it was 2020. I was around, I promise. I had
Well,
social
no,
media. I didn't know about this. How?
yeah, 2022. You can look up like Tonga eruption satellite. Oh, you're muted. Or
Oh, am
I'm.
I?
Oh, there we go. There we go.
Okay.
Sorry.
No worries, no worries. So yeah, I'm just so shocked.
Yeah, it made national news. And it was phenomenally huge. But what was really cool was looking at all of the meteorologists and weather people and atmospheric scientists and other earth scientists on Twitter. Everybody was freaking out and posting all the stuff that they could see and stuff and things. And after a while, and I'm sure it's the same for you, you start to know in your field like who's really trustworthy and who really does have good data. And I came across some very good data from some very reputable people. And so we were able to like piece it apart, and use all of this information from social media and the internet and YouTube that we had found on stream with my community.
Oh,
And
wow.
I sat down with I was in a group of scientists that all different disciplines that are looking at this eruption, and they got they brought their stuff, I brought my stuff, and which was partly my knowledge of how magma chambers work, but also all of this information that I had. And in like a month, I think, gosh, we submitted the first paper on it in February. So a month and a half, I think. We spent like 14-hour days. It was the roughest. But we got the first paper on this eruption published. So I'm very, very proud of that.
That's amazing. Holy smokes.
And yeah, and there's so much about it just like scientifically that is just a treasure trove of new information. But yeah, I think the reason why, in my professional opinion, the reason why it erupted or what triggered that eruption was some involvement between like seawater and the magma system. There is a paper out that was just released that says otherwise, but I don't know the authors and I don't know. I don't agree with it. I don't agree with it.
How dare they publish a paper against your paper? How dare they?
Yeah. But yeah, so that's one of the things that's ongoing, and I don't have the rocks, but I know who does, and they haven't published anything yet, so I'm gonna believe them.
I see.
Yeah, that's my Tonga stuff. So it was so cool to actually do a real research project like with the community on stream and then have that be published.
No,
Like,
that is so cool.
That was
Yeah.
amazing.
With Twitch, especially. That is such a cool thing to do, to work with your Twitch community, to be able to do something like that. That's really awesome. Side note, thank you so much for using kilometers and meters, because I swear, if it was going to be in feet, I would have had to do so many mental maths. I would have needed chat to tell me, what does that mean? I'm very bad with the imperial system. I can't visualize it. I have to convert it.
Oh, I can't either. I actually
Really?
can't either. I know my temperature in Fahrenheit. I'm not good at temperature like human temperatures in Celsius, but everything I do is in like the SI units, and so I don't really think of it in like feet. It's weird. I have to convert.
Nice. Soon, the metric system will convert everyone. But it's good to know. We're starting. Oh, sorry. Go on.
Oh, I was just saying, Dr. Derp is one of my mods, and he's saying some stuff in chat. That's funny.
Measurements in giraffes and hedgehogs. Don't worry. We constantly find American videos, and for some reason, they'll say a unit in feet, or in the imperial system, and then in brackets they'll have or 6 gerbils. I'm like, why couldn't you just convert to meters? Or what's with the 6 gerbils?
Because Americans can't visualize the imperial system either. So you have to give us something real life so that we can compare it against things.
Oh my
That's why
days.
we measure in objects. When we're driving, we don't measure in miles. We measure in time. Like how many hours is it going to take?
Oh, well, that one is okay. That one I understand. As a passenger princess, I need to know the
Okay.
time, not faster traveling. That one I get for sure. um, is a gerbil an SI unit now? We'll make it one day. One day, maybe a lab rat. We'll make lab rats an SI unit. Micromac guy asks, in geology, would there be scope for multi-scale studies? I'm not sure what
Mm.
this question is referring to. Maybe you understand. If so, what are the length scale researchers looking at?
Oh, so I think multi-scale studies can mean a couple different things. It can be either scale in terms of time period, or scale in terms of macro to micro.
Mm-hmm.
And micro, please, if I'm not getting this right, please let me know, because I'm not. That's what I interpret that question to be about. Um, I it really depends on what you're studying. So if you're wanting to study something like why did plate tectonics start, you're going to be looking at, the entirety of Earth's history. But if you're wanting to understand what made this volcano erupt, you might only be looking at a couple weeks to a couple months. It it
Yeah,
same thing with, yeah, it's just very flexible.
makes sense. Mecca is just jumping in to correct and didn't mean in temporal, but he meant in
Oh.
length
Yeah,
scale.
so yeah, it just again depends on what you're looking at.
Mm.
Usually we do use very small things to make big assumptions, and that's just because of scale. Like humans are so tiny. So, compared to a volcano, we're never going to get all the rocks. And we can't sample everything. So you have to pick something that is as representative as possible and then look at that. So I think like, yeah, I don't know if that answers your question. I'm sorry.
Mm. No, no, no. I understand that it's difficult to answer because it's so broad. So it makes sense. But hopefully, Mecca, that was enough to be able to answer it. Ad was asking something else. It was 16 minutes ago. We have a backlog of questions here. I'm keeping
Sorry.
up. So no, no, no. This is awesome. People really want to learn and really want to learn. So that's really, really awesome. But it's just that it'll be topic jumping, so it might frazzle your brain, and I apologize for that. The question was, does the mass of the water in the oceans come into effect, do you think? So I think it was when we were talking
Talking
about.
about Tonga.
Oh, okay.
It does not. I thought it would. Initially, I thought that you could have a nearly infinite supply of seawater that would sustain an eruption. But what it turns out is that there's actually a point at which there's too much water, and then you start to go back into less explosive eruptions. So the peak is like, oh, you're thinking of the position of the plate edges.
Oh,
No, it has absolutely nothing to do with the mass of the ocean. Nothing to do, it's literally just the water that's coming. They're like devolatilizing, coming out of the crystal structure in the mineral and going up and meeting the existing mantle. It lowers its melting temperature so that all of a sudden when you add the water, it starts to kind of melt. It's like when you take ice cream out of the freezer and you eat a little bit, but then if you put it back in, like the next time you pull it out, you're gonna find that it's kind of recrystallized a little bit, and
ah,
that's the process called partial melting. So think about the mantle like that. The mantle is your ice cream. The melt part, like after you add the water and it melting, that's kind of how, when you take an ice cream out of the fridge the second time after you've eaten it, you've got the weird melt parts that are kind of like not quite right. That's partial melting, and that's more of how that would work.
No, that's really good explanation with the ice cream. I like that. That was a really good visual explanation. So this question was clearly one we were talking about, Dante's Peak. Apologies for the delay. Dante's Peak in the movie, they used a walking robot to inspect the volcano. Is that a real thing that is done?
Now we use drones. I don't know about a walking robot. I don't think that's been a thing ever. Back into really until drones became more commonplace. I think even up into the early 2000s, you'd get dropped in a crater via helicopter. So like Mount St. Helens on like 2004 to 2008 was the last time Mount St. Helens erupted, and it was a little dome, like toothpaste being squeezed up out of a tube, kind of that. And I think they dropped people in via helicopter still. I'm not sure when they stopped that, but no, now we use drones. Yeah, drones totally makes it less exciting.
And I don't know, would you know the materials and the structure of these drones to withstand heat and think this?
Just a normal drone. Just a normal drone.
I suppose they don't get too close that it's not too dangerous anyway, heat-wise.
I mean, if it is, you're out of drone.
I suppose.
But not a person.
Another question is, when could be the next eruption on Earth which could be comparable to Pompeii? And I'll ask that first because I have another question on top of that. Is there so from what I understand about volcanoes and earthquakes, they both work on a statistical model, right? On a logarithmic statistical model. Is that fair to say?
There is actually a paper that I love called Lies, Damn Lies, and Statistics in Geology. I love it so
damn
much.
lies?
Lies, comma, damn lies.
Oh, it came up to me autocorrect.
In geology. Okay. And it is a paper. I have a paper copy. I'm like, wish I could pull it up, but I'm not great at multitasking that much. And it shows that statistically speaking, earthquakes are more likely to happen on a Tuesday. Now, is there any correlation? No. Like it's not a real correlation. Like it's not even a real correlation. It's just it happens. You know, it's a good example of how like you could use statistics, but there's zero causation, and it just kind of happens that way. And so you can't, you can't really use. First off, it's impossible to predict any sort of eruption or earthquake. And the reason why I say that is because a prediction implies that you have a time, a place, and a magnitude, and you know all of those things very specifically. So if I were to say, that, and I am saying this for purposes of illustration only, this is not real.
Okay.
if I were to simulate, say, for example, that Mount Hood, which is a volcano here in like right next to Portland. We don't really understand that much about it. So if Mount Hood will erupt on what's today? Today is Wednesday, Friday, May 10th at 11:43 p.m. That is a prediction. What we do instead is forecasting. Not even really as good as the weather, but kind of. And pretty much what we can say is that, this is what we can say is that based on its eruptive history, it is likely that an eruption of this magnitude would happen within the next 1,000 years, something like that. it all kind of depends on the volcano and its history and how much we know about it, because we don't understand a lot about volcanoes, truthfully.
Mm.
Um, Ones that are very active, we understand more for obvious reasons. And so with things like that, we can kind of predict. So for example, there is a volcano that I was like, oh, I should talk about. I can't say its name. What I can say is that based on its eruptive history, we expect that the next eruption would probably cause some like you can estimate the hazards that would probably happen from the next eruption, and that
Mm-hmm.
it might occur within the next like 100 years or even like 50 years.
Mm-hmm.
But that's kind of it.
Okay. So I suppose it's rather than taking all volcanoes and statistically predicting what happens with all volcanoes, you need to take each individual volcano, study it accurate, well, as best as possible, and then that's how you'd make the predictions.
Yes. Yeah.
Okay.
Hmm.
Very interesting. To lead from that, which is my personal question, one of my favorite games, and I can't wait for the part two to come out, is a game called Frostpunk. Have you heard of it?
Mm-mm.
Okay, so it's a simulation building game, but it's set in a universe where a super volcano erupts and the whole world comes in ice age. It's an apocalyptic scenario. I mispronounced that word, but that's what I
Hmm.
was going to say. But the idea behind it is the super volcanoes or volcanoes erupted. The whole idea of the whole clouds covered in soot and things like that. Is this a thing that is a possible end of the world scenario in your mind? Can do super volcanoes exist? Is there this concept or idea amongst other volcano doctors? Do they also think about an end of the world scenario revolving volcanoes?
Um, First off, well, what do you mean by end of the world? The world's gonna be here.
Well, I
It's
suppose
not
us,
it's not
life,
the Earth
life.
we're
Yeah,
worried
yeah,
about.
yeah, yeah. Life. Sorry. To be more specific, Earth is obviously going to still be here. It might just turn
Yeah.
into a different kind of world. But,
Yeah.
I mean, life.
Yeah, yeah, and we've seen it before. Volcanoes have been attributed to many of Earth's great mass extinctions.
Oh, really?
Um, mhm.
They're universally accepted? Because I know, like, for example, dinosaurs is a big topic of
Yeah.
discussion, but we can't say
Well, that's
concretely for sure,
that's
right?
only a big. There's pretty.
Good.
I meteorite. I mean, the Deccan
Oh, okay.
traps were going off, but there's abundant evidence for the meteorite there. That's why the KT boundary is so it's so debated, because what they're debating now is like how much were the dinosaurs already on the way out? Like, what percentage did the meteorite contribute? What percentage did the volcanic eruption contribute to
Mm.
the extinction event? That's what they're arguing about now with that. I think volcano. So there's five major mass extinctions, and it looks like there was a paper in, what is it, in geology. It was a like our journal, geology, that the Earth's largest mass extinction at the end Permian, about 450 million years ago.
450 million? Okay.
Yeah, I'm bad at geologic time, actually. It's what happens. That's what happens when you study stuff that happens right now. I'm not
Mm.
good at the old things. But like 95% of all life on Earth died out. And
Mm.
it's thought that that was caused by a large volcanic eruption. Not really a super eruption, though. There are these things called like large volcanic provinces that will put a bunch of gases and sulfur and things up in the air, and they can erupt for like millions of years at a time. And so that's what like the Deccan traps and the Siberian traps. Here in the US, we have the Columbia flood basalts that cover like most of the Pacific Northwest. Um,
Mm.
and and so the what people think of when they think of like super volcano it's the volcano can have lots of styles of eruptions. You're thinking of a super eruption, and a super eruption is like an 8. It's like the biggest of the big.
Yes.
So with a super eruption, 250 million years ago. Thank you, Otto. Yeah, fully admit I'm bad at the time scale.
Thank
I
you,
have to
Otto.
like look at it every time. What was I gonna say? Oh no, I forgot where I was going with that.
Oh
Oh yeah,
no.
so it took out like 95% of all life on Earth. But somebody in chat brought up like the year without a summer, and that was not a super eruption, and that definitely changed the climate. Pinatubo erupted in 1991, and that lowered global climate. So, but Tonga, which was arguably a larger eruption, arguably, it did not, because the sulfur content was different. So it's not so much just how big the eruption is, it's what is coming out. Because sulfur, like sulfuric gases, will combine with the oxygen in the atmosphere and create these like little sulfate particles. And when those are up there, those reflect light and kind of increase the albedo of the Earth. And so like increase how much sunlight kind of reflects off, and lets the Earth be warmed by sunlight, and that's what drives like those nuclear winters, as they're called. So it's not really like so much there's big soot and stuff in the air. Of course, with a super eruption with an 8, there absolutely would be. There's tons of, it would be black for days, but like, yeah. And there's all sorts of different eruptions with different effects. Yeah, so 1815 was Tambora. That one definitely lowered global temperatures a lot. In 1783, Laka Giger erupted for like 10 months, I want to say, and that combined with a weird weather system and then brought a bunch of death and destruction to Europe. But that's not. Let's go next question. I'm gonna ramble. I ramble. I'm sorry.
No. I love it when scientists ramble. It's actually such a, like, we have a whole tofu rant emote dedicated for ranting. We like this.
Okay.
This is the thing my chat are very, very used to. Welcome in, everyone coming in, and we have Aurelia Studies coming in as well.
Hi.
She's also going to be on a TofuTechTalk exactly next week today. So hopefully we'll be rambling back to back. So I think I've caught up with most questions that chat was asking. I think I kept a track of some questions I wanted to ask. No, that's physics question. Super volcanoes. I asked that one. Okay, I think I've kept track of my questions. Oh, Javin coming in really quickly. No, you purposely put that volcano name in there. Okay, do you know how to pronounce that volcano?
What? Eyjafjallajökull.
You said it so quickly. Holy smokes.
I practiced a lot.
That's class.
Eyjafjallajökull.
She's a magician. That is mad. Oh my days.
Well, I mean, there's so many YouTube videos of everybody like mispronouncing it, all the news people. So I knew that in my lecture I had to pronounce it correctly if I was going to show that video.
Oh, suppose the question was, insert that word, have a positive effect on global warming due to the effect it had on civil aviation.
It did not, and that's a great question, Havensier. So Eyjafjallajökull originally it started erupting, I think, like a month or so before the phase of the eruption that really impacted Europe. And this is, again, the power of water. The first part of that eruption was just normal, like, the Iceland eruptions that have been going on the past couple of years. And then the vent moved, like something stopped it up, and like, just like people, magma takes the path of least resistance. And so it found another way up, and the second vent for I think it was May. If I might have the months wrong, but the second vent opened up underneath a glacier, and the heat from the volcano melted the glacier, caused I think a Yokulp, which is like a blood flow, but it also, I mean, that kind of got into the system and made it so explosive. So when the volcano erupted underneath the glacial meltwater, sorry, interacted with the magma and caused a very large eruption plume. That eruption plume then, like, kind of really the same as in 1783 with Lackagiger, combined with this weird weather system that stuck over Europe, and it brought the ash with it. And so the ash was at the same level the airplanes fly, and it was very, very distributed, like kind of focused. So, sorry, not distributed. It was kind of like focused, and yeah, airplanes and ash don't mix. They don't mix well.
Shocker. Damn.
Mm-hmm. So, but it didn't contribute anything to like the changing climate that I'm aware of. Those aren't very sulfur rich. Like, I don't think really Iceland is. Those aren't really sulfur rich lavas.
Oh. I'm careful to ask this, only to get too specific. What kind of mechanisms or what causes, for example, sulfur to be a major production, or what is this known? Is this studied? Is this
Well, so it's all like what do you start with? If
okay?
you want to make oatmeal raisin cookies, you're
Mm-hmm.
not going to go out and you're not going to buy the stuff to make chocolate chip cookies and expect to end up with oatmeal raisin.
Yes.
Right? So if the original magma source, that bit of the mantle, if it happens to have a lot of sulfur, which, some volcanoes have more sulfur than others. Um, I don't know the different processes that might cause sulfur to accumulate. I can't think of any. I'm genuinely thinking, and which you can tell if you know my face enough. Like I think it all has to start out with initial magma composition.
So basically, location of the volcano itself.
Yeah, it's something to do with like that volcano itself. Yeah, it's like, yeah, it's really complicated. There's no way to like standardize it, unfortunately. Yeah, Otto's got a great point. Each volcano is really unique in its own way. They're just like people.
Everyone, each one. So I suppose that makes sense, especially when we went back to that earlier question about statistical probability of eruption. But rather than looking at volcanoes as a whole, you look at each individual instead, and
Yeah.
talk about. That makes
You
sense.
can make broad generalizations, right? Like you can make the broad generalization that like you know, Americans shoot a bunch of guns. That's not going to be true for every American. But generally speaking, you know? But and so you can say things like uh Hawaiian style eruptions, like I think like South Pacific Ocean Island, La Palma, Tenerife, like those wouldn't have very explosive eruptions because of the type of lava they have. Well, what we now know is they can under very specific conditions if things are just right. So, it's you can make these broad generalizations just like you can about people, but just like with people, it's not always going to fit the bill.
Exactly. And just on the topic of volcanoes are just like people, which is your favorite? I like this question. What is your favorite, not person, a volcano? What is your favorite volcano?
It is Old Lingai, which somebody went before we started. I think it was Oforf talked about soda and vinegar
Yes.
making a volcano. So Old Onion is the real life example of that. And that's why it's my favorite volcano, because it's so weird and so cool, literally, for a magma that, I want to understand why those magmas form how they do. And so it erupts natrocarbonatite lavas, so sort of like sodium bicarbonate based lavas. And yeah, they're very low temperature for a magma, which is like 500 C, 600 C is cold. That's very, very cold, especially for a lava to be liquid. Very low viscosity and erupting at that temperature is very cold. And it's just beautiful. I've been lucky enough to go there, and it's amazing when you're hiking up it. Like the natrocarbonatite flows, they come out black, but then they weather to white, and so it looks like there's snow coming down off the volcano, but it's really the white lava, and it like reflects the moonlight, and it's just so beautiful. It's one of the most amazing places, and I would love to like study it and learn how it works.
Oh wow, that is a really good question, Hax. Good question, Onion.
Yeah, thanks for asking.
As we are approaching the end of the questions, thank you for lasting longer than an hour. I apologize. I always say an hour and a bit, but it lasts always longer than an hour, these Tofu Tech Talks.
That's fine.
I have a personal question. You're my first geologist on this show, and I have to ask, as a physicist, is magma a liquid? And if so, is ice a rock?
Magma is not always a liquid. Magma is a multi-phase, multi-component fluid. I'm glad you asked this question, because liquid hot magma is a very specific definition. Oh. And what we know now is that most magmas aren't liquid hot, right? Is ice a rock? Ice is technically a mineral.
Wait, isn't that a rock then?
A rock is made up of one or more minerals.
Rock is one
or sorry, minerals. Two or more minerals. Two or more minerals. Blah, blah, blah.
Yeah. And so then ice is a mineral. Mm-hmm. But technically water has loads of other stuff in it. And I suppose it's the water that freezes, so that's
it's the water that freezes. You get the crystalline structure. So a mineral has a specific definition, that it's it has a defined chemical composition, crystalline structure, inorganic, crystalline solid. So yeah, ice fits the bill. It technically is a mineral. But magma can have lots of different types of minerals in it. It all comes back to the original magma composition. And usually, so it'll start out as a liquid. Like when the mantle melts, you get a liquid, you get a melt. But if it loses heat, it will start to crystallize, and then you get a liquid plus solid. So multi-phase, multi-component fluid. And then once you get shallow enough, I think low enough pressure is shallow enough, really, then you can exsolve a gaseous phase as well. So. Oh. Okay. But it behaves pretty much, you treat it like a fluid. Treat it like a Bingham fluid.
Makes sense. But the ice cubes in your freezer aren't, because they're man-made. Ooh. Is that true?
Yes, that is true. It has to be like not man-made to be a mineral. It has to
oh my naturally. Days, these definitions. So wait, what are the ice cubes in your freezer then? Are they rocks?
No, they're just ice. It's just a man-made. So like a man-made diamond, a diamond grown in a lab is not a true sensu stricto mineral. Oh. A grown diamond, like a grown diamond from a lab is, we call it's a mineral, but it's a mineral. I like that.
Oh my days. A mineral, does it, please, I'm going to embarrass myself. Mineral did not come from the word mine, M-I-N. It didn't, right? I don't know. Because I'm going to have a blonde moment.
I really don't know. I would think the opposite.
Okay, good.
I would think the word mine came from getting minerals out of the ground.
Oh, still related. Damn it. I still look silly.
No, why?
Oh no, there's blonde moments in figuring out where how words are connected with each other. It didn't connect in my brain for the longest time between mine and mineral
That
until it was
doesn't
put
mean
on
you're
paper.
stupid. It
I
just
know,
means you haven't thought about it.
silly moment, silly moment. That's all. Expert is coming in. Is there any theoretical or practical design to utilize volcanoes for electricity generation? That's
Great question. There is. We do use
yes.
that currently. So geothermal energy is definitely a way that people around the world get electricity. Iceland, definitely. So the Iceland eruption that's been going on, it's made the news because this dike has come in, magma's come up underneath this town and like actually erupted in the town. But the reason why, like this magma body is 5 kilometers beneath a power plant. Well, the power plant is there because that's where the magma body is, and it's harvesting the heat off the magma body, and like that's how people get their heat and electricity on the Reykjavik Peninsula. Um, there's also a place north of San Francisco on the west coast of California called the Clear Lake Volcanic Field. They get electricity there, and so it's more of there's certain types of volcanoes where it is economically viable to generate enough electricity to turn a profit, and
Mm,
that's generally where they're set up.
mm.
So
Basically, in places where it is readily available. It's there's a
mhm.
classification. The geo. I feel like it's a very simple word that I'm getting stuck on.
I mean, just shallow magma body.
Yeah, yeah. No, I'm pausing in the air at the moment. But yeah, that's a
It'll
really good
come.
question. Thank you, Expedus, for coming in.
Hmm.
But yeah, we're finishing up with all the questions. We've caught up with everything. I feel proud of myself. Finally got
Yeah.
through the whole list. Is there anything that you'd like to add or clarify or share more that maybe we didn't pry, but it'll be really interesting to share? I know it's kind of on the spot question, so understandably, if I'm putting you too much on the spot, it's apologies.
Oh no, it's fine. I actually, so there was somebody in chat asked me to talk about my background a
Mm-hmm.
while ago. And just because like so I like to just share my story
Yeah.
and just kind of just because it's not common, and I feel like maybe there's somebody out there who might be in a similar situation that okay, thanks, spooky. Yeah, it was spooky. So I did if oh, there we never mind, here we go.
Welcome in,
We got a
Raiders.
raid.
Sorry for we have all the alerts turned off. We're just in the middle of a little bit of a podcast. Welcome in, Ela. Thank you so much for raiding. Really appreciate it. But we're just in the middle of a podcast interviewing VolcanoDoc, a doctor of volcanoes. Very, very
If you have
smartly.
volcano questions,
Exactly. If you have any volcano questions, even if it's something we probably asked already, it'll probably be nice to review it anyway towards the end of the stream. So that's perfect. We just got a question talking a little bit about Volcano Doc's background and a bit of her story and her adventure.
yeah. So yeah, I got my PhD officially awarded in March of 2022. Um, I did not graduate high school. I'm a high school dropout. And so there is a very, very small percentage of people with doctorate, like not a lot that are in that same situation. Um, and the reason why I dropped out of high school is because I got pregnant and didn't know what I was going to do. I ended up dropping out of school because I needed the money. So I dropped out of high school. I worked full time as a paralegal and like went to community college, which was like, I don't know, junior college. I don't know how it works in Ireland, sorry.
No
Um
worries.
but
We know community. Yeah, we understand community college. Yeah.
yeah. So I did that, and I was going to be a lawyer, and then I transferred to the university in the city where I was living at, um, and I was working full time as a lawyer or as a paralegal, going to school part time, and I decided I wanted to do environmental law, which is a practice like in the US where sue mining companies for trashing, leaving land filthy and things like that. And when I took my first mineralogy class, I was like, oh my God, there's shiny minerals. This is so cool. I love it.
Magpie.
And, and, like the minerals got me hooked, but I took a really cool class called Archaeology of Ancient Disasters, and that kind of solidified my interest in volcanoes.
That sounds
cool. But the whole time I was, doing university part-time, working full-time, single mom, and it's hard, but if I was very, very lucky. I had a lot of help from friends and some family, and then I got accepted to go to grad school. So my daughter and I moved to California to go to grad school, and kind of same thing. I did TAing and research, and also like moonlighted as a tutor because grad school doesn't pay very much, and had my daughter with me the whole time. And she ended up, so I defended my thesis in December 2021. So that's when I consider I graduated, because the defense is what matters.
Yeah. Everything else is a formality afterwards.
Yeah. So I defended in 2021, in December 2021, which was 6 months after my daughter graduated high school.
That's amazing.
So, I'm really proud of her.
What about you? You had to be very proud of yourself, surely.
Well, yeah, but I'm just proud of her because she did something that neither her dad or I did. Like, her dad and I both dropped out of high school, and so I think it's really cool that she was able to do that. And I just, I've worked really, really hard to get where I'm at, and I've had a lot of help, and it took a long time, and it was not without a lot of sacrifice. But I want to share I like sharing my story because you never know what kind of situation people are in. And I want people to know that you don't have to be a stereotype. It's like, definitely, I got very, very lucky. And it was not without a lot of hard work and a lot of luck that I am where I am today. But you don't have to be what people think you are. And I guess that's kind of why I like to share my story.
No, that's a perfect. Oh. Why are there ninjas cutting onions? No, that is such a really amazing story. Absolutely amazing that, again, the story of like you didn't finish high school and yet here you are standing with a doctorate in one of the most coolest fields of science. Let's be honest.
It is objectively pretty cool.
I mean, like, we can say, oh, my field of science is cool, but let's be honest. Dinosaurs and volcanoes is where it's at. Sorry.
A little bit. They're pretty cool.
That's what all got us inspired in science when we were kids, to be fair. No, that story is absolutely amazing. Thank you so much for sharing it. That was really, really, no, it was absolutely. And I hope chat took some inspiration.
I hope there's somebody out there who hears this, and hopefully it can get you feeling a little bit better in your heart about possibilities.
Absolutely amazing. So, VolcanoDoc's profile is in the title. If you click over the username, not only do you get direct link to her Twitch to follow, yes, chat, my chat especially, you better follow. I'm coming for you. But also make sure to follow other social medias. I know you use Twitter possibly, and I actually tried. You don't have Instagram.
I do. I'm the VolcanoDoc on Instagram.
I was looking for you. Okay.
VolcanoDoc.
The VolcanoDoc. Thank you.
Yeah. I'm probably most active on Twitch though.
Okay, okay.
Yeah.
Find you in other streaming communities as well.
Twitch and Twitter. Yeah, Twitch and Twitter.
Perfect. Thank you so much for coming out on the show. I really appreciate the time you took out. You weren't feeling the best at some point and you came striking, powered through today. So thank you so much for that. I really, really appreciate that.
Well, thank you.
Powered through.
Thank you so much, and thank you so much to chat. Like, you guys had amazing questions. Like, this is why I like science communication on Twitch, to share knowledge with people who wouldn't get the chance to ask these questions otherwise of an expert.
And even if they do get the chance, if the anonymity is kind of nice in the sense, do you know, I'm sure you know, like when you're in a lecture hall, you're not going to ask the question to the lecturer because you're very embarrassed about speaking in public. But I feel like that protection of being online allows you to ask any question and you're safe to do so, if that makes sense.
Yeah, exactly. I really do like it.
So yes. Oh, we have already loads of congrats coming in. I was literally going to say to give some pom poms and some cheer in the chat as a big
Well,
thank you
thank
for
you.
VolcanoDoc. You're not streaming today, are you?
No, I
Okay.
am streaming on Sunday.
It's just
Probably Sunday
Sundays, is it?
morning. I do just Sundays, and then I do one Saturday a month. I have coffee with a scientist, and I have that scheduled on my Twitch page.
Nice.
So I usually try to stick to whatever schedule is there. And then yeah, and who knows? My life is changing. I don't know. I'm gonna be a professor, so things are very up in the air.
Yes. Oh, it must be so weird to be a professor and then also be a Twitch streamer. Your students might find you. It might be really cool.
But we'll see.
Yeah, I'm also worried because, like, again, I was also a lecturer just for a few weeks there. I was like, what if my students find me? It's going to be so weird if they're going to. We'll see how
I
it
don't know.
goes.
We'll see.
All
So
right.
thank you all so much.
So, chat, what I'm going to do is I'm going to go into the AFK screen because I need to figure out someone to raid. I see Tarek and Medjay. If you guys could figure out for me, could you help me out and help me who to raid over to? And then apologize on my behalf that I'm not going to be there because I'd like to give my private farewell to Volcano. But again, yes, Otto Potato, I'm so glad you were here for this talk. I was hoping you'd be excited.
Yeah, thank you so much for coming in, Otto.
Thank you so much, chat. And mods, could you give me a quick in the chat who to raid over? Really appreciate it. And I'll see you guys. Goodbye, VolcanoDoc. Salute you.
Involved in an ongoing battle with
It must
Frank
be
McCoy.
one-sided. I don't know anything about it.
Yeah, well,